Here are some of the most commonly missed problems from the exam. We'll just kind of run through those. So I think in the first one, the biggest issue was just figuring out how much was actually in the account. So we had two different formulas for this, and the one that I think most people used was just the simple interest formula that only gives you how much interest was earned, but not how much is in the account. So a lot of folks forgot to add in that original amount. Remember, these are randomized, so your numbers might be a little bit different. So instead of 8,000, you might have had 9 or 10 or 11,000, whatever. Instead of 2.3%, you might have had 1.9 or 2.1 or something like that. So these numbers be a little bit different. Anyway, the formula that I think a lot of folks ended up using was taking that principal amount, multiplying by the interest rate. So we're at P for the principal, R for the rate, so 0.023. And if you didn't have it as a decimal, obviously that would be a bit of a problem, but I think we were okay on that. And then times time, so every year we're earning that same amount, 2.3%. So in this case, times 15. So we get 2760, right? We should kind of know that this number can't be the answer because we started with 8,000. So I shouldn't, right? If I'm earning interest, I shouldn't have my value go down. So instead we're saying, oh, that's the interest I earned. So I should take that and add on the original amount that was already in there. So we should have, 10,760 as our actual answer there. For the next one, we've got 3,000 in a savings account. This one, the biggest thing on this one is that it's compounded quarterly. So if you went into the Tvm Solver, which I think a lot of folks did, and we said, okay, cool, we're earning interest over 4 years. I think here's the biggest problem. We did something like 4 times 12 because we're so used to monthly compounds. That's not actually the case, right? We're not going to compound 48 times. We're actually only going to compound 4 times 4, 16 times, because we're doing this quarterly, so 4 times a year. Your interest rate is 5. Your present value would be 3,000. You're not making any payments. And so you're going to find this future value. Now I'm going to show you what happens when we do this, and this number is not going to be correct either. So if we hit alpha and solve, you're going to get a number like this, 3206 and 37 cents. That's not exactly accurate either because we have compounds per year and payments per year as 12. Those would have to change. If we're doing this quarterly, we'd have to change those to 4, and we're going to see that this number ends up being quite different from what we just saw. So this, right, you can go through the Tvm Solver, but we didn't really do problems like this in the solver. The way that we actually did this, and we can see if these things are even correct, right? The way that we actually did this was we used the 1 plus APR over n to the n times t. That's one of our basic formulas. So we had 3,000 was our initial amount, 1 plus APR is 0.05. We're going to do this quarterly, so divide by 4. And then we're going to take this to the power of n times t. Okay, well, remember, n is number of compounds per year. So usually we're doing monthly. This was the one question that I switched that up and changed it. That's why I italicized quarterly. So we're not going to do 4 times 12, right? We're doing 4 times 4. We have 16 total compounds. And that's where we get 36.59 and 67 cents. This one is similar to the previous one, though. We have to be really careful about, do we want to know how much is in the account or how much interest was earned? So in this case, we just want the interest, right? 3,000 of those of these dollars were already in there. That was our investment. So let's subtract 3,000, and here's the result we're going to get. We're going to get 6.59 and 67 cents. So this, there were, again, a couple of components to this, but this one was just one of our initial, kind of straightforward, one-time payment type of deal. Okay, for the next one, we have a mortgage situation, so we'll definitely want to use the Tvm Solver. So this thing's a 30-year mortgage, so 30 times 12 for n. Our interest rate here, 4.1. Again, your numbers might be different from this. So just kind of think about if you were working through with your numbers, if you can make sense of these ones, it's pretty easy to translate from one to another. And then our present value for the loan, 380,000. Our future value, because it's a mortgage, our future value should be down to 0. I had changed these before. Make sure these are back to 12. Because of course we are doing monthly payments and monthly compounds. So what we don't know is what is that monthly payment. So we have to do alpha and solve. So we're not asked about this at all, about the monthly payment in particular, but we do need to solve for this. So now everything is set up. So this is all locked in. And so we can exit back out. If we're interested in just the interest, then we'd say, okay, cool, let me go back into apps and finance, but instead of doing the solver, we can scroll down. We've used these 3 functions before, right? The balance function, the sum of the principal, which is really how much equity we've built, right? How much we've actually paid toward the loan, and then the sum of the interest. So we want the sum of the interest. Remember, this is from what payment to what payment. So from payment 1 through the first 10 years. So you can do 10 times 12, or you can just say, oh, okay, that's 120 payments. If you do that in this particular case, right, again, it's going to be different depending on which situation you were in. You've got about 141-ish thousand just in interest. If you're looking at total payments, or equity built, or what the balance is, those things are going to be really different. But just interest, we use that sum of the interest formula. And if you need a reminder of this again, like how a couple more examples, look through the notes, look through the videos. I made those before. Okay. The last one is, again, we're going to use the solver. This is the one question I had on here about ARMs, because those are kind of longer questions in general. And so I only put one on there, and it was the same weight as some of the others. Normally I would weight this problem a little bit more heavily, but because we're in the online environment, I figured, this is the question we're most likely to struggle with. So I wasn't terribly surprised that there was just a mix of answers for this, but it was worth basically the same amount of points as all the other ones. So, you can look at some of these and say like, oh, cool, this simple interest problem is worth the same as an adjusted rate mortgage problem. That, like I said, normally would not be the case. Anyway, so hopefully that worked in your favor to devalue this one. So we have a 15-year mortgage. That means we're doing 15 times 12 for N. Our interest rate in this case is 3.4. Our present value for the loan is 200,000. And right, our future value should always be 0 for this type of scenario. And our payment, we're going to solve for that. So keep in mind, even though this is a 5-1 ARM, the overall is a 15-year mortgage. So that's why our N dealt with that 15. Right? For N, we always say, how many payments do I still owe? It doesn't matter that our rate is going to change after 5 years. We just kind of work under the assumption it stays 3.4 forever, even though we know that won't actually happen. So, okay, we have this payment, $14.19 and 96 cents. So that's our original monthly payment for those first 5 years. If we want to know the new monthly payment, there's one very important piece of information we need to have, which is, okay, we'll know that we have 10 years left, right? We're 5 years in. So after 5 years, we got 10 years left. We know that the interest rate jumps. We know that our future value is still 0, but what's going to change is that present value. We shouldn't still owe the full 200,000 after 5 years. So here's where we want to find our balance. So this is another one of those functions that was tied in around the same time as this sum of the interest. So do apps, finance, and then again, instead of going to the solver, scroll down until you reach the balance function. And the balance function does not have a starting and ending value. It's just an ending value. So we want to know 5 years in. So 5 times 12, or you might have already known that was 60. So after 60 payments, meaning after 5 years, here's the balance we still owe. So we still owe, we started at 200,000. We still owe $144,278.71 if we're rounding. So when we go back into the solver, right, we update everything. We say, well, we've got 10 years left on the loan at this point, right? We're 5 years in. The interest rate jumped up to 5.2. How much do we owe? Well, we still owe $144,278.71. And so here's where we calculate our new payment now that everything is in. So our new payment is $1,544.44. And that is pretty much it. We could ask more questions about this. We could certainly we've done a lot of different types of problems with adjusted rate mortgage, but this one is at least fairly straightforward. There was only one piece you had to kind of record and pull back into the problem and then just update everything else. So hopefully that works. Hopefully that makes sense. Hopefully these problems make a little bit more sense because you will be seeing ones that are very, very, very similar on the final exam.